Mammoths, a kind of proboscidean that inhabited extensive areas of Europe, North America and North Asia and became extinct at the end of the last ice age, shortly before the decline of Pleistocene. The mammoth is usually associated with a woolly mammoth, which died off towards the end of the last ice age, so the majority of representatives of the species didn't have thick hair. They became extinct about 10,000 before Christ. The significant and dramatic climate changes that occurred at the turn of Pleistocene and Holocene, to which mammoths failed to adapt, were one of the reasons for their extinction.
The last glacial period was the most recent glacial period within the current ice age, occurring during the last years of the Pleistocene, from approximately 110,000 to 10,000 years ago.
When did they live?
Pleistocene, a geological period in Earth's history which ended about 10,000 years ago, with the current warming called interglacial, also referred to as Holocene. It was in that period that mammoths died off because of climate adaptation problems.
Pleistocene is known mainly from its climate fluctuations, glacial cycles and thaws. The causes are still a subject of exploration. At the end of the Pleistocene and the beginning of Holocene, many huge mammals have vanished, like for example woolly mammoth or saber-toothed tiger, that are considered to be symbols of the Ice Age. The beginning of the Holocene, in the ice core record, appears as a violent change of the climate, consisting of quick warming and transition from a glacial to interglacial climate mode. That is the time when the last phase of the late glacial Younger Dryas ended. Significant element of environmental changes between Pleistocene and Holocene was rapid increase in average annual temperatures, which resulted in the emergence of new plant communities at lowlands. At the end of the glacial period, within a few decades, the summer months temperatures have risen in the northern and central Europe by 7 to 8 Celsius degrees. The consequence of temperature change was an increase in evaporation of groundwater, which entailed droughts in valleys, and consequently dramatic changes in the vegetation, followed by significant landscape transformation. The external factors giving rise to climate change include changes in the supply of solar radiation, in the configuration of continents and oceans, the formation and disappearance of sea currents, volcanic eruptions, and tectonic movements that modify the circulation slowly, but their effect lasts forever. Topography has a significant impact on the circulation of air, the exchange of heat and moisture transport. Volcanic processes affect the climate most immediately. The thing about the volcanoes is that particularly those explosive thrown into the atmosphere huge amounts of dust. The particles that breach the stratosphere, they can remain there for up to 10 years. They absorb and scatter solar radiation, thereby reducing the fall of the Earth's surface, thus causing heating of the stratosphere and cool the basal layers of the atmosphere.
But the main reason of mammoths' extinction was climate changes caused by Earth's axis deviation.
Periodic changes in the Earth's orbital parameters. Main reason of mammoth extinction. Through time the Earth has cycled through hot and cold periods known as glacial and interglacials. It is the Milankovitch cycles which are the main factor influencing the amount of solar radiation hitting the Earth's surface. The Milankovitch cycles are known as the changes into the pattern of the Earth's orbit defined by three major variations. The effects would have had maximum northern hemisphere hitting 9,000 years ago when axial tilt was 24 degrees and nearest approach to the Sun, the calculated Milankovitch forcing would have provided 8% more solar radiation. First, eccentricity. Over a 100-year cycle, the orbit of the Earth changes from near circular to a thin ellipse and back again due to the gravitational pull of the Sun. Second, obliquity. Obliquity is the tilt of the Earth ranging from 22.1 to 24.5 degrees over a 31,000-year cycle. The larger the angle, the larger the difference between summer and winter. Third, precession. Precession refers to the wobbling of the Earth as it rotates. This is when the axis rotates in a circular motion to over 26,000-year period, also affecting the seasons. What is most remarkable about the mid-Holocene is that we now have a good understanding of both the global patterns of temperature change during that period and what caused them. It appears clear that changes in the Earth's orbit have been operated slowly over thousands and millions of years to change the amount of solar radiation reaching each latitudinal band of the Earth during each month. These orbital changes can be easily calculated and predict that the northern hemisphere should have been warmer than today during the mid-Holocene in the summer and colder in the winter. The paleoclimatic data for the mid-Holocene shows these expected changes. However, there is no evidence to show that the average annual mid-Holocene temperature was warmer than today's temperatures.
There appeared hypotheses that similar change of climate occurred during last 100 years, and its cause also were astronomical changes. Is it the truth? No. Current changing of climate is caused by the greenhouse effect, not change of Earth's axis. In summary, the mid-Holocene roughly 6,000 years ago was generally warmer than today, but only in summer and only in the northern hemisphere. Moreover, we clearly know that cause of this natural warming and know without doubt that this proven astronomical climate forcing mechanism cannot be responsible for the warming over the last 100 years.
Because of the global warming at the end of the Pleistocene, mammoths extincted. In our times, we can also notice a considerable increase of temperature, although we know that interglacial warming was caused by a change of axis, and today's warming is caused by the greenhouse effect.
In Europe, the early parts of the interglacial, as it was in transition from the preceding glacial stage, was distinguished by treeless, grassy plains that eventually gave way to pine forest and then extensive oak and hazel forest as the climate warmed. Global sea level was estimated to have been at least 5 meters higher, resulting from a reduction in size of Greenland and Antarctical sheets. Northwestern Europe, with its crust being isostatically depressed from the weight of ice cover from the previous glaciation, was flooded by the Ionian Sea, which connected the Barents and the North Seas, leaving Scandinavia as an island.
Overall, the early interglacial climate in the North and Western Europe was characterized as being predominantly oceanic, i.e. with relatively cool summers, comparatively warm winters, and reliable precipitation, with a modern Mediterranean climate in southern Europe, while other regions of the northern hemisphere maintained a more seasonal continental climate with warmer summers and colder winters. So here we have a warmer, wetter world than today's, with higher sea levels, smaller ice sheets, but a level of atmospheric CO2 much lower than today. Does this mean that increasing levels of CO2 do not cause global warming after all? Climate always changes, and we have nothing to worry about.
I'm much too fast to take that test. Changes. Turn and face the strain. Changes. Don't wanna be a richer man. Changes. Turn and face the strain. Changes. It's gonna have to be a different man.